A great detective fully solves the glue paradox new riddle of induction. We will not only explain what is right, but also the psychology behind why things are wrong. Glue is the color that is green before 2049 and blue after 2050. Before 2049, we repeatedly confirmed that the color of emeralds was glue. Can we say that the stone will still be glue after 2050? This is incorrect because without physical color change, emeralds would remain green. This paradox leads to strange inductive reasoning. A common explanation is that there are predicates that can be used in inductive reasoning, and predicates that should not be used. Let's simplify the problem. We have a device with button A, button B, and lamp C. We are verifying the hypothesis, if O or B then C. We have confirmed multiple times that pressing A lights up C, and the hypothesis is verified. Without ever pressing B, we have inferred that pressing B will light up C. This hypothesis can be expressed separately as, if A then C, and, if B then C. We should consider that only the fact that pressing A lights up C has been verified. When expressed as logical OR, it is clear that separate verification is required. At the very least, we have learned that we should not include logical OR in the hypothesis. Let's create a hypothesis that doesn't use logical sum OR. If button X then C. We press button X, which is randomly selected using a random number. We try this multiple times and the hypothesis is verified. If we press button B, will the light turn on? However, it's possible that only button A was selected randomly by chance. If button X then C has been verified, but if button B then C has not. If there is a discrepancy between what is verified and what we want to know, we cannot make an inference. So, if you press a button chosen at random, will the lamp light up? Since this is the same as the tested hypothesis, it seems possible to guess. However, if you choose randomly, buttons A and B each have a 50% chance. The past probabilities were just biased by chance, and the next time they will be chosen fairly. There is a 50% chance that you will press button B, which you have never pressed before. Even in this example, we cannot infer that the lamp will light up. The same thing happens in statistics. Suppose the aim is to obtain statistics that are unbiased between men and women. So, a random sample is taken from a population with a 50% male to female ratio. Can we say that statistics obtained in this way are unbiased between men and women? If, by chance, a man was selected with a 70% probability, then the statistics obtained will be biased. The sample should have been taken so that the number of men and women was equal. Let's consider the source of these misunderstandings in inductive reasoning. First, a hypothesis is formulated. A sample is drawn from the population and tested to see if it matches the hypothesis. It doesn't matter whether the sample is random or not. It is a mistake to assume that this testing makes the original hypothesis correct. All we know is the truth of the sample we drew. If we could only assert correctness for the extracted sample, we would not be able to make predictions. This is because, while we can extract the results of pressing a button in the past, we cannot extract the results of pressing a button in the future. Therefore, we impose the precondition that time is not distinguished. This way, past samples become valid samples for inferring the future. We are also free to impose the precondition that buttons are not distinguished. Inductive inference will produce a variety of different results depending on the preconditions. Unlike deduction, the same result will not be obtained regardless of who makes the inference. By the way, according to statistics from the Ministry of Health, Labor and Welfare, you need to eat 350 grams of vegetables a day to be healthy. Strawberries, melons, and watermelons are vegetables, so eat lots of them. Eating 350 grams of nutritious cucumbers is also good. It seems that people think that as long as the vegetables are the same weight, they will have exactly the same effect on health. By exploiting paradoxes, you can create convenient statistics. People at the Ministry of Health, Labor and Welfare are obligated to show that you can eat 350 grams of raw spinach every day and still be healthy. That's all.